So the current flowing through the shunt is I minus Ig. Distance between the planet and the sun has to be small, has to be minimum. If the temperature is increased to 3T, the voltage across the capacitor and resistor. So what I do, I multiply and divide by 2. The next question. The question says, a planet revolves around the sun in an elliptical orbit. So there is a planet which is revolving round the sun in an elliptical orbit. The linear speed, I am not concerned about angular speed. The linear speed of the planet will be maximum at which point? So the problem says, this is the position of the sun and the planet is revolving in an elliptical orbit. 4 points on the orbit is given, A, B, C, D. I have to analyze at which point linear speed is maximum. Now, from Kepler's law, exclusively Kepler's second law, which is called the law of areas. Kepler second law and consider marde, law of areas and kardvi. Linear speed of the planet is maximum when it is close to the sun. Yavaga linear speed maximum agirutte when the planet is close to the sun. Distance between the planet and the sun has to be small, has to be minimum. For which point? You observe the point A, very close to the sun. Therefore, the linear speed of the planet is maximum at the point A. So the second option, point A, is the correct answer. Next one, fluid mechanics. Many a times you people don't pick up intensely with this chapter, but might cost. They are all simple questions. Horizontal tube. Illondu horizontal tube kottidare, which has non-uniform cross-sectional area. The tube has non-uniform cross-sectional area and it has radius of 0.1 meter and 0.05 meter at M and N. So M, the radius is 0.1 meter, at N 0.05 meter. Streamline flow of liquid. The rate of liquid flow is, andre, at which part of the tube the liquid flows with maximum velocity, non-uniform cross-sectional area. ಇಲ್ಲಿ ರೇಡಿಯಸ್ ಜಾಸ್ತಿ ಇದೆ, ಇಲ್ಲಿ ರೇಡಿಯಸ್ ಕಮ್ಮಿ ಇದೆ. ಯಾವ ಭಾಗದಲ್ಲಿ liquid flows with maximum velocity? Anywhere can I equate area of a tube with velocity of flow? Very good. Equation of continuity, which told A1 V1 is always A2 V2. This is called equation of continuity, from which A into V is always a constant. And this implies velocity is inversely proportional to area. Velocity of liquid flow is inversely proportional to area. ಅಂದ್ರೆ ಎಲ್ಲಿ ಏರಿಯಾ ಜಾಸ್ತಿ ಇರುತ್ತೆ ಅಲ್ಲಿ ವೆಲಾಸಿಟಿ ಕಮ್ಮಿ ಇರುತ್ತೆ. Where velocity is more, area should be less. Very evidently, so here at n, velocity is more because area is less. So it is greater at n than m. Next one. A resistor and a capacitor. A resistor and a capacitor are connected in series with an AC source. A resistor and a capacitor connected in series with an AC source. Potential drop across the capacitor is 5 volts. Potential drop across the resistor is 12 volts. Then what is the applied voltage? Potential drop across the capacitor 5 volts. Potential drop across the resistor 12 volts. Then what is the applied voltage? Students, illi applied voltage is the resultant of the voltage across the capacitor and resistor. Okay, so when you say applied voltage, it is nothing but the resultant voltage of what? Potential across the capacitor and potential across the resistor. So, applied voltage is root of VC square plus VR square. Root VC square, 5 square is 25 plus 144, root 169. So 13 volts is the answer. Very simple. What game we have? Know the expressions, arrive at the answer. The amount of heat energy radiated by a metal, given out by a metal at a temperature T is capital E. Andre, when the temperature is capital T, the amount of heat energy given out by a metal is E, then what will be the temperature or what will be the energy if the temperature is increased to 3T? Temperature T ಆಗಿದ್ದಾಗ ಎಷ್ಟು ಎನರ್ಜಿ ರೇಡಿಯೇಟ್ ಆಗಿದೆ? E. ಅದೇ ಟೆಂಪರೇಚರ್ ನ 3T ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದ್ರೆ how much of energy is radiated? Which law of radiation can I use here? Yes, Stephen's law, which says E is proportional to T to the power 4. Energy given out by a heated body per second per unit area is directly proportional to the 4th power of the temperature. So, E dash will be proportional to 3T to the power 4. 3 times the energy, E dash, or E dash by E will be 3T by 4 divided by T by 4, which is 81E. So the answer is 81E. Now, the angle of minimum deviation, small d na capital D na? Very good. Capital D, small d, angle of total deviation. So small d for an incident light ray on an equilateral prism, angle of minimum deviation for light incident on equilateral prism is equal to the refracting angle. Refracting angle is nothing but A. Then I have to calculate refracting index. What is A for an equilateral prism, students? Angle of refraction or angle of the prism. Yes, for an equilateral prism is 60 degrees. Which means this is also equal to D from the question. Clear kottidare. Angle of minimum deviation is equal to refracting angle. How do I calculate refractive index? A beautifully defined formula. N is sin A plus D divided by 2 divided by sin A divided by 2, or N equals 60 plus 60 by 2, 120 by 2. Again this is sin 60 divided by sin 30. So the answer has to be root 3. Root 3 by 2 into 2 by 1. So the answer is root 3. The next one, students, already simple, competent. The answer is 1, 1, 0. Now, quite interesting problem. Stationary point source, a source which is at rest of sound, emits sound uniformly in all directions in a non-absorbing medium. 2 points P and Q are at distances of 4 meters and 9 meters from the source. The ratio of the amplitudes of the waves at P and Q has to be calculated. He says, the source is at rest and it emits sound in all directions. They have considered 2 points P and Q at a distance 4 meter and 9 meter from the source. My first objective is to understand the relationship between intensity of sound and source. Observer source hatra iddaga intensity of sound ಜಾಸ್ತಿ ಇರುತ್ತೆ ಅಲ್ವಾ. ನಾವೊಂದು ಸೋರ್ಸ್ ಹತ್ರ ಹೋದ್ರೆ ಸೌಂಡ್ ಜೋರಾಗಿ ಕೇಳಿಸುತ್ತೆ, which means distance is less, intensity is maximum. As you go away from the source, as the distance increases, intensity decreases. So please to understand, you need to know this relation. Intensity is 1 by r square. It is inversely related to square of the distance. Therefore, I1 by I2 will be 9 by 4 whole square. Alva? Inversely related agide. So, I1 by I2 is 9 by 4. But how is amplitude related to intensity? Very good. I is proportional to A square. Again, you should know intensity is directly proportional to square of the amplitude, which means A1 by A2 is root I1 by I2. So, I1 by I2 is so much square. When you take the root, this is nothing but 9 by 4. So, the ratio of the amplitude is 9 divided by 4. Again, a beautiful question. A galvanometer of resistance 240 ohms allows only 4% of the main current after shunting a resistance. Only 4% of the main current is flowing through the galvanometer. Then what is the value of the shunt resistance? I have to calculate the value of this shunt resistance. Now, there is a galvanometer. A shunt resistance is connected in parallel with it. I, main current, Ig, current flowing through the galvanometer, I comes out. What is the current flowing through the shunt? If you consider this as the node, I is entering the node, so I is positive. Ig is going out of the node. KCL says current going out of the node is negative. So I minus Ig. So the current flowing through the shunt is I minus Ig. My dear students, galvanometer and shunt are connected in parallel, G and S. So what should remain same? Potential across them. So potential difference across G is equal to potential difference across S because they are connected in parallel. What is the current flowing through the galvanometer? See, potential difference, Ohm's law, I into R. So this is Ig into G equals I minus Ig into S. I want the value of S. Now, what is Ig? Only 4% of the main current flows through the galvanometer, not the entire main current, 4%. So this is 4 into 100 into 1. How much is G? 240. And again this is 1 minus Ig, 4 by 100, or I can say this as I. Simplify for yes, 10 ohms will be the answer. So the current flowing through the shunt is 10, or the resistance across the galvanometer, shunt resistance is 10 ohms. The phenomenon in which proton flips, again from the previous syllabus, nuclear magnetic resonance. Now, there is an equation. Y is 3 sine pi t by 2 minus x by 4. This is given. Is it in the standard form? Illa. So a 2 pi is missing here. So multiply and divide by 2. 3 sine 2 pi t divided by 2 I have multiplied. So minus x by 8. Now is it in the standard form? Yes. So y equals a sine 2 pi t divided by capital T minus x divided by lambda. So compare here. T is equal to 4 seconds. Lambda is 8 meters. Now, velocity will be lambda by T. So this is 8 by 4, 2 meter per second. I want the distance traveled by the wave in 5 seconds. So distance is velocity into time. 2 into 5, which is 10 meters. So the answer is 10 meters. Again, I don't go to this at all because elementary particles, you don't have any idea about quarks. So as I told, in the repository when we come back for the note discussion, there I take up these questions. Again, this is already done. 4 root 2 will be the answer. Quite interesting question. A cylindrical tube open at both the ends has a fundamental frequency of 390 hertz. When the cylindrical tube is there, it is opened at both the ends, which means when it is behaving as an open pipe, the cylindrical tube behaves as an open pipe. What is the fundamental frequency of an open pipe? V by 2L, and according to the problem, this is 390 hertz. A cylindrical tube behaving as an open pipe, fundamental frequency of an open pipe V by 2L, and it is already given to be 390 hertz in air. Now, if 1/4 of the tube is immersed vertically in water, I am immersing 1/4 of the tube in water. 1/4 of the tube na water ಒಳಗೆ immerse ಮಾಡಿದೆ. Then what is its fundamental frequency? My dear students, when I immerse 1/4 of the tube in water, ನೀರ್ ಒಳಗೆ immerse ಮಾಡಿದಾಗ, now the tube behaves as a closed pipe. One end is immersed in water, other end is open, so it is a closed pipe whose fundamental frequency is V divided by 4L. Now what is L? 1/4 immerse adre 3/4 remains. So F dash is V divided by 4, 3 by 4L, or V divided by 3L. See, L, 1/4 of the length is immersed. 1/4 ಆ ಪೈಪ್ ನ ಒಳಗಡೆ ಇಮರ್ಸ್ ಮಾಡಿದೀನಿ. ಉಳ್ಕೊಡೋ ಲೆಂತ್ ಎಷ್ಟು? 3 by 4L. This 4 gets cancelled. V by 3L. I know what is V by 2L. So what I do, I multiply and divide by 2. So here F dash will be 2 by 3 into V by 2L. Just alternating this expression, because I have V by 2L, 390 hertz. So 2 by 3, 390. So the answer is 260 hertz. Surface temperature of stars, always using Wien's displacement law. Yeah, this is an assignment. Quite number of circuits we have solved. I want you all to solve this and get me the answer. A parallel beam of light is incident on the converging lens parallel to the principal axis. A parallel beam of light is falling on the converging lens parallel to the principal axis. As we go away from the lens, on the other side of the principal axis, what should happen to intensity of light? It should first increase and then decrease. Why? Because here, first light converges. There is convergence of light, and second, there is divergence of light. Since first light converges, its intensity has to increase. Then it diverges, therefore its intensity has to decrease. Continuous emission spectrum is produced by incandescent electric lamp. All other three, mercury vapor, sodium vapor, sun, will produce band absorption spectrum. Incandescent electric light will produce continuous emission spectrum. This goes for a toss. Clinically, the data is not sufficient to move. A ray of light is incident on a plane mirror at an angle of 60 degrees. Angle of deviation produced by the mirror. Angle of deviation is 180 minus I plus R, or 180 minus 2I, because the first law of reflection says angle of incidence is equal to angle of reflection. 180 minus 2 into 60, 120. So 60 degree is the answer. The next question. The electric potential at a point x, y, z is given by V equals 3x square. The electric field at a point 2 meter, 0 and 1 meter has to be calculated. Now we say potential is 3x square. Pertaining to this potential, how do we calculate the electric field? Where we clearly know E is minus dV by dx, relationship between electric field and electric potential. That means E is minus 6x. Now substituting the given points, E becomes minus 12 volt per meter when substituting 2, 0, minus 6. So the relevant answer is minus 12 volt per meter.